So what we're going to be talking about today is the H100 Special Functions. So kind of what makes the H100 different than the other drives. Like the IS7, the G100, the S100, those are kind of considered more general purpose or more geared towards industrial applications, whereas the H100 is a dedicated fan and pump drive. So you're going to see a lot of stuff on this drive that's going to be standard, geared towards, municipal pumping applications or irrigation, agriculture, commercial buildings for, fans or chillers and stuff like that. So that's kind of what we're going to be going over. So it's kind of like a features and benefits thing. So this will show you some reasons why you'd want to use like an H100 for, applications like that instead of like a general purpose drive. Okay. And so we're going to start out with the kind of most basic stuff here, and then we're going to kind of work our way through all of the features and functions. First is just like the general specs, which is important to know because we're going to talk about some of the capacities and stuff. So first question you should be asking when you're picking out a drive is, well, what motor are you connecting this to? 10 horse, 20 horse, 100 horse, 600 horse. And then, what's the voltage? Are you running 230, you're running 480, single phase, three phase? So if you look at the top right here, you can see that the H100 is rated up to 800 horsepower for 480 volts, and then 25 horsepower for 230 volts. And then also notice there's that ND, so that's a normal duty. So this is a normal duty drive. It's 120% overload for 60 seconds. And once we get to the larger drives, it's 110% overload for 60 seconds. So this is meant for variable torque applications, which typically require that lower overload capacity. So there's no selectability on the H100. The input voltage range, we got two of them. We got the 230 volt class, which is good for 200 to 240. So that'll cover, 208, 230, 240, and everything in between there. And then we have the 480 volt one, which goes all the way down to 380 because it is a global product. Most of us over here will probably be using 480 volts. So something in red here is the communication is we have a built-in backnet. So the H100 drive is the only LS drive with the built-in backnet. It's a MSTP. We don't have the backnet IP yet. That's something that I believe we're working on, or it's on the list. So I see some other questions coming up. So Ethernet, we are working on a Ethernet module for the H100. The main reason we're working on that is because we're going to do a lot of utilities or municipal applications, and those guys are using Ethernet to connect to their SCADA. So we are working on a Ethernet IP option card. The ones that are listed in red here are actually the standard ones. So BACnet is built in, Metasys is built in, Modbus RTU is built in. It's just a parameter to change what protocol you're using. Option cards, we have the LonWorks card. Not too common, but it's there. Then we are working on the Ethernet IP card. So yeah, that's a good question. And the cards that we make are selectable for Ethernet and Modbus TCP. So it's the same card all in one. You just flip a switch, dip switch. It's a V/F drive, so that's a volts per frequency. We also have slip compensation, which may be useful for compressors where you need to get some higher starting torque. Carrier frequency ranges from 1 to 15K. These are all IP20 drives, just like all of our other drives. And then you can get NEMA 1 kits or conduit kits that give you the NEMA 1 rating as an option. All the standard certifications are okay. UL, CUL, CE, or RoHS. The plenum rating is something that's nice. You could actually mount the drive in a plenum, which some of the HVAC guys care about. And then we have the conformal coating type 3 on all of our printed circuit boards. So for those of you guys that have been around for, I don't know, maybe more than a year with us, the drive used to go up to 125 horsepower, but within the past year, it's expanded up to 800 horsepower. So a pretty broad range. This drive goes the highest as far as horsepower out of all of our drives. So you should be able to kind of throw it at anything you need. So here's some more specifications. So this is just kind of showing the control terminals and how the LCD keypad is removable. I'm not going to read through all this because some of it's kind of redundant. We have the built-in communications that we just read through. We have the optional LANWorks card with an optional Ethernet card coming out soon. We have the built-in EMC filter on the 480 volt ones. And there's a few sizes that don't have the EMC filters. I think there's a slide that comes up about that. So it depends if you need it or not. And then the built-in dynamic brake chopper is up to 30 horsepower standard. Well, 40 horsepower since this is normal duty. Most of the time, 99% of the time, can't say never, you shouldn't need dynamic braking because on fans and pumps, usually it's not critical to stop them in a short amount of time. And you should just be able to extend out your deceleration time to counter like an overvoltage trip. We do have that zero stack capability. What that is that's the side-by-side mounting. So you can mount them 2 millimeters side by side up to 40 horsepower. And then the bigger guys, once you go 50 horsepower and up, then it's 2 inches side by side. So here's just the control wire terminals, and the reason why I'm showing this, it might be overly technical for some of you guys, but a lot of the functions we're going to be talking about are directly related to inputs and outputs. So you could close outputs, at certain times or certain speeds. You could have an input close to tell the drive to do something. So we just figured it'd be good to mention it. So we're talking about the I/O. So the digital inputs, we have 7 of them. P1 through P7, all the defaults are here: forward, reverse, reset, external trip, and so on. We have 2 analog inputs. We have a current one and a voltage one, and then the second current one, we could actually flip a switch and change it to a voltage, so we could run 2 voltage analog inputs. So those are typically going to be connected to your BAS system, your PLC, transducer perhaps, or a speed pot, items like that. We have 2 analog outputs, so all the outputs are on the right side of this drawing. So we have AO1, AO2, which is our analog outputs. We have the S plus and S minus. That's your communications, which you would use for the backnet, the Modbus, whatever you select in the drive. And then this drive has the most relay outputs. So it has 5 relay outputs. And if you look closely on that bottom line, they're all rated at 5 amps, 250 volts. So this drive has the most robust, highest amperage rated relays out of all of our drives. And that's because we have functions like damper control, and a damper is going to pull a little bit more amperage than like a small LED light or indicator, for example. So that's why they're a little bit more robust. And all those are fully programmable too, which we'll show you at the end. We have a slide that lists all the different functions. There's a million of them. So here's just a little bit more of the specs. This is just talking about the terminal block, kind of what it looks like, how the layout is. There's some dip switches on there. They're pretty tiny. Usually when I talk to people on the phone and I'm like, oh, look for that dip switch. And they're like, that's a dip switch? Just looks like a little black speck on the printed circuit board. Yeah, that's a dip switch. So we have 5 of them. We have a termination resistor on there that's built in. So that's termination for like an end-of-line drive on a communication network, like Modbus, for example. We have our PNP NPN switch, so we could switch between syncing and sourcing, essentially. So it's a little bit versatile for the PLC or controller connection. And then we have the 2 analog inputs. We could switch from voltage to PTC, which PTC would be like a temperature feedback from a motor, if you're going to be doing that. So that's a nice option to have standard. Just flip your switch. Then we have I2V2, so that's another switch. You could switch between 4 to 20 and 0 to 10 volts, 4 to 20 milliamps to 0 to 10 volts DC. And then we have our analog output that we could switch from voltage to current. So there's some flexibility in here. It's pretty much just changing a dip switch, so no parameters associated with them. Besides the functionality, that's a parameter. All right, so one of the things different about the H100, and people might overlook, is the keypad. Is it's an HOA keypad. So HOA for Handoff Auto. This is the standard keypad, and it's kind of there for the HVAC market. So for those of you guys that get involved with HVAC and read through those fun specs that are 50 pages or whatever, They'll usually spec in the VFDs that they need like an HOA keypad. Okay, so that's the reason why the H100 has an HOA keypad, just to meet specs. So I'm not going to go through all of these, but I'm just going to show you the bottom ones. Here we go. Our Handoff Auto is on the bottom here. So hand operation is kind of like for testing, or maybe for running when the rest of your system goes down. You press your hand key and you can adjust your speed on the keypad. 30 hertz, 40 hertz, 60 hertz, whatever you want. Okay, so it's kind of like an override. Off, of course, will stop you. It should stop you in hand or in auto. And then auto is typically what's going to be running off of your BAS or your building management system, or however you have your drive set up. It could be a PID loop. It's all fully programmable. So yeah, those three keys are kind of what make this, I guess, the start of what makes this an HVAC drive. Yeah, here's pinpointing the hand, which I just explained. Yeah, so hand disables PID, runs straight off the keypad. Auto runs you in your auto programming mode. Yeah, so we're going to start getting into some different functions here, but first up, I'll show you guys, we're going to get into a lot of these are kind of like, special, more advanced features. Most of the time you may not need them, but from a sales or from like a startup perspective, it's kind of good to know they're there. These functions will eliminate the need for a PLC or an external controller because all the logic is in the drive. But we would recommend starting out with just following our quick start reference. These are available on our website, on our knowledge base. You could always email us. We could send it to you. But these quick start references, if you haven't used them yet, they're just short, kind of 2-page flyers almost, that just tell you the basics of how to wire up the drive, how to navigate the keypad, and then how to do basic parameters like, motor data. How do you start the drive? How do you stop it? How do you control the speed? And maybe some safety functions in there or protection stuff as well. We recommend always starting out with following the quick start reference, and then you could add on the functions we're going to start talking about next afterwards. Kind of build it up and make the drive a little bit more smarter and tailor it to your application. The H100 is the only drive with a real-time clock, commonly called an RTC for short. So for those of you guys that didn't know about that, and have set up many H100 drives, the clock is actually disabled by default, so that might be why you didn't know about it. There's as we're showing you in this picture here, if you pop off that front cover, there's a battery. It's like one of those quarter size 2032 batteries. There's a little plastic slip behind that battery, so you remove the slip, and then the battery makes contact, and then you could set your clock. So that's the first thing you got to do if you want to set your clock. So you might ask, well, what's the purpose of the clock? A few different things. Even if you're not going to use it for, sequencing timers and stuff like that, one of the most useful things I find with this is it timestamps all of your trips. So nobody's standing in front of a drive, all day and just staring at the screen. So many times, the drive will trip out. Maybe somebody resets it, and then the next day you get a call and say, yeah, it tripped yesterday. I don't know what it was. Well, when was it? Maybe this time. I don't know. But this will actually store the actual fault, like all the drives do, and it'll actually timestamp it. So it'll say, oh, this happened at 6 in the morning, and then here's all the details of what happened with that trip at 6 in the morning. So it'll store the 5 most recent trips and the time it happened. Then I'll show you in a couple of slides. We could also set sequence timers once you enable this, enable the battery. Oh, and if you look on the bottom here, this is a common question, is, how long does the battery last? Well, it depends on how often the drive is powered up. Because if the drive is powered up, you're not really using the battery. You're only using the battery when the drive is powered down. So they say about 6 years if you're powered on. And then if you're powered off, so if you remove the slip and you leave the drive powered off, or you pull it and it's sitting in the shelf with the battery enabled, you're only going to get about 2 to 3 years. You can buy these batteries anywhere. It's a standard battery. It's not proprietary. So, and then we do have a low battery trip. So if the battery is ever getting low, you're going to get a low warning. So you get a chance to order up a battery and then swap it out. So when it comes to setting up scheduling and sequencing, which I'm going to show you guys in the next slide, what we'd recommend is actually using DriveView 9 because it's a little bit more visual. You could do it on the keypad, but it's a little bit tedious and cumbersome. So we do have software called DriveView9. This is the latest and greatest VFD programming software from us. You can download it at no cost on our website. Just go to lselectricamerica.com, click the download section, click software, and it's going to be like the first or second thing there. So you can download that. The H100 is pretty nice because it has a USB port on it. So it's not a USB micro. It's a USB mini. Okay, so it's like a little bit bigger. That's showing the cable connection there on the top right, so you can see what kind of plug you would use. So you probably have a big box of those cables sitting somewhere at home. So you'd use that, plug it in, then you can read parameters, write parameters. You can do drive monitoring. You can do trending. You could output reports. Make parameter lists. Make backups. So there's a lot of stuff you could do with that software. It's completely free. Yeah, so here's that scheduling I was alluding to. So once you enable the clock, you could set up to 8 different event schedules. Okay, so you could set things to happen on certain days. You have 30 different functions that are available. So FX is forward run, RX is reverse run. Then there's step frequencies, there's PID. So you could enable PID, disable PID. You could set a lower speed at night, perhaps, maybe a higher speed during the day. It also comes standard with the daylight savings time. So they call it summertime in this keypad. So you could set the drive to do the time switch, automatically for you. And then, you could change it to be, the different displays, but you're probably going to want it in the USA display. So it's a pretty nice setup. So a lot of times guys will need external timers or some kind of external equipment to run like a schedule, but you could do it all in the H100 just by enabling the battery. And again, we'd recommend using the DriveView9 when setting it up. It makes it a little bit easier. This is something new on the H100. I think the H100 and maybe the S100 are the only ones that have this Auto Torque Boost 2, which is kind of a newer feature. What this is Auto Torque Boost, and I know John could attest to this as well in tech support, is we always joke and say Auto Torque Boost fixes all your issues. If we ever have anybody calling up and they're like, hey, this thing isn't starting up, I need more starting torque, or my voltage is kind of acting funny on the output, usually if we set up automatic torque boost, it just fixes everything most of the time. So there's a manual torque boost, which is what the drive defaults to. And when we're talking about torque boost, we're talking about boosting up the output voltage going to the motor. So when you boost up your output voltage, you should theoretically increase your torque. So manual torque boost is just a percentage. I think it defaults to 2 or 3%. So it's going to boost up your voltage 2 or 3%. It's not dynamic at all. Then there's Auto Torque Boost 1, which is the second one we're listing here. That one, it works okay, but you got to do an auto tune. And if you guys don't know what an auto tune is, that's entering in all your motor data and going to another parameter and kind of hitting the go button. But then if you're going to do a rotational auto tune where the motor rotates, you got to uncouple your loads. You have to pull off your pulleys or belts and stuff. And people don't like to do that because it's extra work. So they rather do something like Auto 2, where you don't need to do any auto tuning. Okay, less work. You just set up one parameter and then you're good to go. There is a gain you can adjust. I've honestly never adjusted the gain. Usually I just set it to Auto Torque Boost 2 and everything's good to go. So it works out pretty well. It's just one parameter change. TRV 15 is the parameter. There is this kind of flow chart on the bottom here, which is showing you how it works. We don't need to go through all of that. We also do have like an application note. So if you guys have been cruising around on our new knowledge base, there's an application note which explains this Auto Torque Boost 2. So feel free to look up that. So here's a feature that's more geared towards the HVAC guys, which is fire mode. You may hear it like called like smoke purge or like a fireman's override or something like that. So whenever there's like an emergency situation, such as like a fire in a building and it's connected to like your fire switch or whatever, your intake and exhaust fans are typically going to want to run continuously, and it's going to be like a run to fail. Okay, so we're purging the smoke, we're exhausting the smoke out of the building. okay? And we're going to ignore trips, like maybe like an external trip or something like that. We're going to ignore trips like that, but we're still going to look at trips like a short circuit, overcurrent, over voltage, ground fault. And the way I think of it is we're still going to look at those trips because those are trips that could cause more fires. So we don't want to add any fuel to the fire if the building's on fire, okay? And how this works is this is a digital input signal. So that's what I was showing you guys earlier. There's like that P1 through P7. So you pick out what one you're going to use. I'm going to pick out P3. I'm going to program it to fire mode. And you can see this time sequence right here. Let's see. Yeah, so hopefully you guys can see my my mouse on here. So as the fire mode signal goes on, it's going to pick whatever direction. You could have it run forward or reverse, depending if you're running an intake or an exhaust fan, right? You don't want to be pulling in fresh air and adding more fuel to the fire again. So you could pick the direction. Then you're going to pick your fire mode frequency, which is usually 60 hertz. And then this is just saying how we're ignoring trips. If there's any trip, it's going to ignore it, unless it's like one of the trips on this list here. So we got 1, 2, 3, 4 different trips that are still considered actual trips. All right, so here's another one. This is a really nice feature for pumps, which is called load tuning. Okay, so we briefly mentioned auto tuning. Auto tuning is tuning the drive to match up with the motor. So you put all your motor parameters in there. How many poles is the motor? What's the rated slip or the RPM of the motor? What's the kilowatt capacity? Actually, it'll be horsepower on the H100, which is nice for us Americans. So you plug in all that stuff and you do an auto tune. Okay, that gives you a little bit more efficient operation. Squeezes the most volts per amps out of the drive. Load tuning is kind of tuning the actual tuning the output V by F to the load. Okay, so when I say the load, typically this is going to be used on pumps, because if you do a load tune, you're going to be able to do some more advanced features, which we'll mention next, which is like a pump clean function or under load protection. So like a belt break or broken shaft or pump clean, if something gets jammed up. So this diagram on the left is showing the actual load tune. So it's going to go up to a certain frequency, run for 10 seconds, get some different data back. Then it's going to jump up to the high frequency, okay? And it's going to do some calculations. It's going to take those frequencies, plug them into this formula, look at the current, and then try to figure out, where we are on a pump curve, okay? And it's going to do the same for the power, okay? Power and current, and then frequency here. So if you do a load tune, which is, again, it's like a secondary auto tune, then you can do stuff like this. Pump clean. This is a great feature. So if you ever get into like wastewater, those guys always are like have like a function called like deragging or something like that. That's what a pump clean is, or anti-jam. So if there's anything stuck in the impeller, we could detect that. We could do it automatically, or we could do it with a switch, and we could have the drive rock forward and backward until we get rid of that solid or that debris that's jammed up in the pump. So there's a few different ways that you could enable this. You could have it enabled based on a current or a power consumption. So if we ever hit like a high load, like a high amperage, then it'll automatically go into a pump clean. Or you could program one of those digital inputs. So again, P1 through P7 are fully programmable. So you could pick one and say, hey, I want this to be pump clean. And then you have a switch that you flip on, and then it goes into this pump clean mode. And down here, you can kind of see how the operation is going to work, or the sequence. So let's say you flip a switch, pump clean goes active. There's a delay time. It runs forward for a certain amount of time. Then it stops, runs reverse. You can set the frequency. You could set the delay time. You could set how long. And then you could also set how many times you want it to run back and forth. So it's all fully programmable. There's like almost a whole parameter group in I think it's the AP2 group that shows how to set this up. Okay. So pretty easy to set up and pretty versatile. Again, these functions are standard on the drive to kind of eliminate external equipment. You can just program it right into the VFD. So under load protection, this is something that's going to work best if you do that load tuning that we just mentioned. So under load would be used to trigger like a trip or a warning. So the difference between a trip and a warning is going to keep running, but just flash like on the keypad, underload, underload, underload. Whereas a trip will flash underload and it'll stop you. Okay, so that's the difference between the two. So you can set the trip to, coast to stop, or you could set it to a ramp to stop, follow your deceleration rate. You can see on the right here, we have our underload operation. Here's that load curve, which is programmed from that load tune. And then we have a bandwidth. If we ever drop outside of that bandwidth, so if we ever have low amperage, depending on the speed, right? Because we're running variable torque loads here. So the current is going to change based on the speed. Okay, that's what a variable torque load is right here. So if we ever drop to our low current, you have like a delay time. If you look over here, there's a warning time, there's a UL trip time. So whatever time you go past is going to trigger something to happen, whether it's a warning or a trip, and it'll stop operations. So this can be used for like belt breaks, right? Let's say you're running a fan and then the belt falls off or the belt snaps or something. That fan could be, well, the fan won't be running, but the motor will be running indefinitely, and nobody will know until it gets hot and somebody complains, or until maybe a maintenance guy notices that something's wrong and there's like very low amperage on the keypad. So instead of nobody knowing about it, you could have a digital output, which we talked about. We have 5 digital outputs. We could program a digital output to tell somebody or tell a BAS system that there's a problem. We hit underload. We could have a light come on. We could have a buzzer come on. There's all kinds of different things we could do. This is another feature. So this presentation will be sent out. I would say shoot me an email. I think we'll have some. I think we have emails at the end of this presentation. I'll have to double check. If not, you could shoot me a message and I'll email you. Let's see. Hold on. Ron's got a question. You show power and current measurement. So this drive can measure horsepower in kilowatts. Yes. As far as I know, I'm pretty sure all of our drives can measure. They'll measure kilowatts, like current power consumption. So, in the H100, something we don't talk about out here because I found nobody ever does it. It's like more of like a marketing thing. Is we could do the energy savings calculator. So the drive has where you could put in your price per kilowatt, and it records the the amount of power you're consuming. So it'll calculate how much energy or how much money you're spending to run the motor, and then there's like a energy savings calculator that shows how much you're saving versus running across the line. That's actually built into the H100 too. It's called like a Payback Counter. I've never really used it. Even in my previous position, one of our competitors had the same thing, and people were always like, "Oh, that's nice," and they never used it. So it's kind of more of like a marketing thing or whatever. So yeah, good question. Yeah, so here's the another question here. Will the drive do load sharing? Oh yeah, we'll get to that. I'll show you guys load sharing. So hold that thought. We have a slide on that. All right, so we have a soft fill. So here's a soft fill. We're talking about pump stuff. So I think most of the slides are going to switch over to pumping things now. So soft fill is commonly used in irrigation. You may hear it called like pre-PID or like a pipe fill or something like that. What we're doing is if you have like, let's say a large irrigation system and you power it up in the morning and you start building up pressure and all the pipes are totally empty, well, that could cause some pressure surges, some water hammering, and then some cavitation in the pump because, everything's dry. So it's going to run as fast as it can to build up the pressure because pressure is going to start out at 0. So what soft fill is it's a way to slowly fill the pipes and prevent, those things from happening. So to slowly build up system pressure until you reach, a certain level that you program, and then it switches over to regular PID regulation. So that's what these tables are showing here. There's like a pre-PID delay time, It's fully programmable. These AP22, AP24, 25, these are, and these PIDs, these are all parameters that we're looking at here. So you have a pre-PID delay time, so you could run it like a fixed speed. You could have it gradually step up, okay? So you'll see your frequency creep up until you hit your soft fill level. Once you hit that level, which is typically a pressure point that's somewhat close to your set point, that's going to automatically flip over to your normal PID operation. So that's what soft fill is. Then we have a broken pipe detection. So this is kind of similar to the underload detection, similar but different. You could have a trip or a warning happen whenever we have like a low pressure and a high speed. Okay, so if we are running a PID loop, so what was it, last week or maybe 2 weeks ago? Some of you guys probably, hopefully, watched our PID webinar. If not, it's on our YouTube page. You can check it out. But when you enable PID, that's what all these functions are kind of related to. Okay, so that's your pressure loop. So if you're running PID, and let's say you have a 60 psi set point, but your feedback is down at 20 or 30 psi, and then your motor is running 60 hertz. It's running full speed because it's trying to get up to that 60 psi reference. So if we're looking at this table here, you know, our feedback is really far off from our reference. So you have this line right here. This is like your detection level, okay? So if there's a difference, a large difference between your set point and your feedback, you have a delay time, just like everything else. You hit those criteria, and then you could trip out, or you could do a warning, okay? Because there may be a broken pipe. There may be a valve that's open that shouldn't be open, and you're just spraying water all over. So there's a problem. That's what the purpose of the broken pipe detection is. So yeah, pretty easy to set up, pretty useful. Again, commonly used in irrigation market, but it can be used on any pumping system where you want to monitor the pressure and, you know, make sure everything is as it should be. Yeah, so this next one is flow compensation. So this is most commonly also used in irrigation market, especially when you have very long lengths of pipe, or if you're ever like pumping on an incline. So if you're ever going uphill, you're going to have a significant pressure loss. Or if you have very long pipe, that's going to also cause a pressure loss. So depending on where your transducer is, so your transducer would be your feedback device telling you what the pressure is in the line, and then where your pump is, you may need to use flow compensation to compensate for the difference. Okay, so in order to compensate for this loss, what the drive will do is it's going to automatically increase the output frequency to kind of boost up that pressure and compensate for the losses. Okay. So it's pretty easy to use. What you do is you add in this parameter, which is called a set point compensation value, which that compensation value is meant to cancel out the losses that you're assuming are in your system. And as you can kind of see here, so you have, you know, a few different pressures because you're losing pressure, but you can have this compensated pressure reference here, which is this line that's creeping up a little bit here. So that's your set point compensation value there. There's a formula. I won't bore you with the formula, but we use this a few times, yeah, for like very, very large systems with long pipes. And this is another pumping one. So as I mentioned, there's a lot of pumping ones here. So start ramp and end ramp. This is good for submersibles because submersible motors or submersible pumps have a thrust bearing in there, and that thrust bearing needs to get up to speed, typically 30 hertz within 1 second. So we could lubricate the bearings and not burn out the bearings. If you have like a very slow acceleration time on a submersible pump, it'll be okay, but it's not going to be okay for very long. You could damage those bearings. So this start ramp, end ramp, what it's going to do is you have a short acceleration time up to whatever your lower limit is. So let's use the example I just mentioned. Typically it's 30 hertz. So you set your lower limit to 30 hertz, and then you have a 1 second acceleration time to get up to 30 hertz. And then after that, you can have a longer acceleration time. Okay. And then same thing on the decel. Maybe a long decel until you hit that minimum, then you want to ramp down fast because you don't want to be riding on those thrust bearings when they're not, you know, properly lubricated and riding on the water that you're pumping. We have a Tcell valve ramp. So this is going to be used when you have like a check valve. So it's a way to prevent against water hammering. So it's very kind of similar to what we were just talking about, but it's a valve ramp for like a check valve. So it'll ramp down pretty quick, so you don't have any like chattering or water hammering. Here's one of the HVAC functions here, which is a damper control. So if you think back when we were talking about the relays, so we have 5 relay outputs on the H100, and they're all rated at 5 amps. So I believe they rated them at 5 amps, or put in the bigger relays for stuff like this, where you can do damper control. So what a damper is just like a damper in a ventilation system that's opening and closing. So if there's a damper in the system, you can set up the drive to control the damper and then also receive feedback via like an end switch signal. So how it works is you give the driver run command, and then you give it a damper open input. And then there's the delay time, so the damper should be open, let's say, in 20 seconds. If we don't hit that end switch, so we don't get an input saying that the damper's open within 20 seconds, the driver will trip out saying something's jammed up, something's frozen, something mechanically is wrong. But if it does open in time, well, then what it's going to do is it's just going to start running. Okay, so you'll see your output frequency run like normal. So they're showing like kind of 3 different conditions here. But yeah, pretty easy to set up. I think it's like 3 or 4 parameters. A lot of times this is controlled by like a BAS system, but we can do it in the drive itself if like a building doesn't have a BAS system. And we also have the lubrication control. So this is lubrication for a pump that's going to need to be like pre-lubed pretty much. Okay, so when you give the driver run command, if you program a relay output for lubrication, when you give the driver run command, it's going to pre-lube the motor, and so you can set a time that it's going to take to lube up that motor. So very easy thing to set up, just a couple parameters like a time and a relay output. This one's useful. I think this is only on the H100 if I remember, which is motor preheat. So motor preheat is a way to eliminate the condensation that can form in a motor. Okay, so if there's like a temperature difference inside of the motor versus the outdoor, depending on where the motor is installed, that can cause condensation to form on the motor windings. So then when you start up a motor, you could be getting ground faults or over voltages or weird issues like that caused by the condensation. So what motor preheat is what it does is it injects a small amount of DC current from the drive into the motor, and it keeps the windings warm, just warm enough so that there's no condensation allowed to form. Okay, so this looks like a complicated, table here, but really all you're doing is you're flipping on a signal, which is your preheat signal. There's like a delay time, and then this waveform right here, this like scribbly sawtooth waveform, that would be your motor preheat. Okay. Actually, sorry, this is your regular operation here. That's trying to show our PWM. The motor preheat would just be like a solid signal. That's like these squares. And then you could set a preheat duty cycle so it goes on and off. And then there's like a current level that typically you'd want pretty low because you are injecting DC into the motor. All right, so yeah, a few more functions here that you may run into. Level detection. Again, this level detection is typically used with PID as well. So you could set like a high or a low level detection, based on a preset. And there's 13 different ones you could select from. So on the right here, you could do just current level detection. You could do based on voltages, kilowatts, horsepower, V1, V2, I2, which are analog inputs. Or you can do it based on feedback, which I think would be most common. So you hit like a low pressure or a high pressure PSI, then you could trip the drive out. Okay, so it's very similar. You have a level, you have a delay time, and then you could program a relay. It's like kind of like always the same 3 things you guys are hopefully noticing for these functions. If you could set up one, you could set up any of them. They're very, very similar. They'll do slightly different things. So it looks like I lied to you guys. I said we weren't going to talk about this, but here's that payback counter. So you can calculate the energy saved, your CO2 carbon footprint, be green kind of thing. So you go in and you put your cost per kilowatt in this parameter, AP289. So, 10 cents, 20 cents, whatever your rate is. And then it's going to calculate your kilowatts per hour saved, your megawatts per hour saved, and then it actually calculates a dollar amount too. It gives you some CO2 factors. And there's like a reset, so you can reset it and then check it again. So we do have this. I haven't heard anybody use it, but I guess for you salespeoples, you could always share that as like a nice feature just to see how much money you're saving, see what your return on investment is, because that's kind of what it's all about, right? And then we have the power on run delay. Yeah, so this is good because if we ever have like a power interruption, after a momentary power loss, all the loads come on together, right? Everything connected to the utility is going to try to start up. So it might be a good idea to put a power on run delay, so that way you're not coming on with everything else. So you can wait 5 seconds, 10 seconds, whatever you need to do, and then after the line stabilizes, not all that inrush from everybody else jumping on the line, then you're okay to run the drive. This might be especially useful if you're running like a 600 horsepower motor. So, no big deal to wait an extra 10 or 20 seconds. Okay. So essentially all it's doing is even if you have a run command signal there, it's going to put a delay in front of there. So it's kind of like just like a run delay. One of the more advanced features we have, you may or may not use, is our KEB, which we've enhanced on the H100. So it's kinetic energy buffering. What it's doing is if you ever have like a power loss, the motor will typically still be spinning as long as there's a decent amount of inertia in that motor or on that load. So what we're going to do is when the motor's freewheeling, it's acting as a generator. So it's regenerating. We'll take that regenerative energy from the inertia and we're going to use that to keep the power up in the drive, keep the DC power up, and that'll prevent a low voltage trip. Okay, so there's one less trip you got to worry about. Use that energy to keep the drive powered up. Okay, and then if the power ever comes back, the drive's going to try to start back up. Okay, yeah, so this is what KEB is, and so that's kind of what they're showing here. Is your voltage drops. There's your low voltage level trip here, but instead of hitting that low voltage level trip, you hit this start level for KEB, and that tries to keep your voltage, your DC voltage stable. Okay, so you have a somewhat stable bus capacitors on there. And then if the power ever came back, you'd see it just come back on like normal, uninterrupted, just a way to eliminate a trip. So here's the load sharing that I saw somebody asked a question about. So we have two different options or flavors for load sharing. First is this multiple motor control. So multiple motor control is like commonly called like a contact or lag. Okay, so you have one drive which is running a main motor, and that's going to be a variable speed one because that's running off the drive. Okay, and then we have those 5 relays that we could run to motor starters for like a cross-line starts on auxiliary motors. So we could have, excuse me, we could have up to 6 motors running off of one drive. Okay, one of them is going to be running variable speed, and the other 5 are going to be running like across the line starts based on these relays, giving them a run command or closing a coil or whatever. Okay, so we have a few people that use this. They really like it. It's pretty cost effective because you only need one drive and some contactors and overloads here. So you could have interlocks on here that'll like enable or disable the system. Auto exchange, which is like a alternation kind of deal. There's some like bypass features in here that you could be triggering with like based on feedback value. And yeah, this is all PID related. So you have to be running PID to be using this multiple motor control. Yeah, so this is like the most basic load sharing we do on the H100. So it's all one parameter group, AP1 or something like that to set this up. Then we have this lead lag firmware. Okay, so what this is right now it's like a custom firmware that we can flash to you guys. And we're working on making it a standard firmware, so you won't need to make any special requests. So what this is one drive per motor, okay? And you can run up to 8 drives. So let's say you want to do 8 drives. So you'd buy 8 drives, and then you'd get some wires, and you'd put them between each drive, and that would be your Modbus connection. And then you do your programming, which is pretty easy. We have a few startup guides on this. You set, the drives addresses to 1 to 8, and then the drives are automatically going to regulate the pressure. They're automatically going to stage and destage based on what's required. So do we need to run 1 drive, 2 drives, all the drives? And then they'll also automatically alternate too. So every 24 hours, you could have them alternate, or you could change it to be whatever you want. You could have them alternate based on first in, last out, first in, first out. That's what the FILO and the FIFO is. You could have them use a single transducer, so all 8 drives on 1 transducer. Or you could have multiple transducers. So if one transducer goes down, it looks at the next transducer. Okay. So this is the more the higher level load sharing. Okay, you're going to buy more drives. It's a lot more versatile, a lot more features there. The whole purpose of this is to eliminate like a SCADA system, eliminate PLC programming, and do it all within the pump programming. So we also have a few customers using this, and it works out pretty well. So we do have a flyer on that, so you could always, I think you can get that off of our website, or just get it from one of your local sales guys. So speaking of PID, which we've been talking about almost the whole hour, is we also have this enhanced sleep and wake up. We have a sleep boost, we have a sleep mode, we have wake up delay, we have wake up mode. And the whole purpose of this sleep, if you're not aware of it yet, we did talk about a couple weeks ago in that PID webinar. So sleep is pretty much putting the motor to sleep and stopping it when demand is low. Okay, so we consume less energy. So what they're showing us here is if your feedback is up here, okay, and then your reference is here, you have a sleep boost. So before you go to sleep, okay, so it's like demand drops. It's like kind of pressing the gas in your car so you can coast a little bit longer. So you can sleep a little bit longer. That's the best metaphor I have for you there. So here's the sleep boost, and then it'll wake up based on a pressure drop. So once demand increases again, that's your wake up level, and then the drive starts as normal. So it's another way to automate the process. Okay, so here is all of the programming options available for your I/O. So thinking back to that first slide, we had P1 through P7 for our inputs. That's everything on the left right here for digital inputs. So we have forward, we have reverse, we have a reset, which is a remote reset, external trip, we have speed, low, medium, high, we have XL, decel switches. You could flip a switch on and it'll go to a different XL or decel rate. Run enable, like a safety interlock or something. 3-wire for push buttons. Second source to switch between analog inputs or communications or whatever. We have up-down control, which is called MOP sometimes. Analog input holds. Got a bunch of PID stuff here. 5 different interlocks you could program. External trips. Damper open. PID steps. So you could have like a selector switch that switches between different set points. So quite a long list here. Pretty long list for the digital output. So that's where you're talking about relay 1 through 5. We have frequency detection. That's this FDT. So frequency detection 1, 2, 3, 4. That's different levels and bandwidth for the detection of what the drive is running at. Then we have our overload, underload, fan warning. Pretty much anything that we have a trip for, you could program an output to trigger. We have timers, we have level detection, pump clean active, damper air, lubrication mode, yeah, capacitor warning mode if your capacitors are reaching their life. Yeah, plenty of different options for that too. Just to kind of make you guys aware. All right, so that was what I had for all the features and kind of benefits and stuff. So let me just show you guys the kind of other things we're offering, which is in the same realm as the H100. Is we do have the SP100. Hopefully you guys are aware of this. This is a nice package, available up to 75 horsepower in 480 volt, and then up to 25 horsepower in the 230 volt guy. So this is like a standard bypass, 3-contactor, NEMA 1 rated. It's on the shelf, ready to go. So if you order it, by 2 o'clock Central Time, then you can get it, shipped out the same day. So we got built-in manual motor starters, and then recently we added in circuit breakers. So if you guys need like 100K AIC package, which is a common spec in the HVAC market, these are all 100K now. Okay, so keep that in mind. It's all LS components in there, so you'll have like an electronic motor overload, circuit breaker contactors. So yeah, it's a nice package, pretty compact, reasonably priced, and we can do that same day shipping. So keep that in mind. And it's just an H100 on a mechanical bypass. So if you could program an H100, if you want any of those features we just talked about, it's all there. You just got to program it. So pretty easy. We are also offering some standard panel solutions too. So we can do 3-contactor bypasses up to 400 horsepower. NEMA 1, NEMA 12, NEMA 3Rs are the options. And we have a few different options for like, reactors and DC link chokes and stuff like that. HOA switches, temperature options. And then we have a non-bypass option as well. The non-bypass is available. Same thing, up to 400 horsepower, and HOA switches and all that good stuff. So feel free to inquire about that if you ever have an opportunity come up. All right, so that was all I had. Sorry, I don't have a thing slide for this. So I'll have to add one, I guess. So yeah, if you guys want these slides, feel free to like maybe throw your email in the chat. And then we're going to be putting this on our YouTube page. Usually it takes us a couple days to get around to it. So if you have any questions, feel free to throw them in the chat. Hang around. We can answer those. Otherwise, thanks guys for coming. So we're about an hour. So thank you guys for coming. Any questions? Let us know. And hopefully we'll see you guys at the one which is coming up next week. That's a good question that I failed to mention. Can we have single phase input with 3-phase output? Yes, we can have that for all of our drives, and we've actually been UL tested and UL listed to run single phase in, 3-phase output, all the way up to 400 horsepower. So as I mentioned, the H100 goes up to 800 horsepower. So it's approximately a 50% D rate. So you can take that 800 horsepower and apply it to a 400 horsepower motor with a single phase in. You're gonna have some big breakers and some big input leads, but it's all been UL listed and tested. So yeah, that's a possibility. It's a good question too, because a lot of these pump guys will have a single phase only out in the middle of the field. So that's a good thing to know. All right, well, I don't see any more questions, so I'm going to go ahead and end the meeting. Thanks again, guys, for coming, and we'll see you all next week.